Morning. So in continuation of previous video, so in the previous video we discussed the decoder with enable input and how do we use that to construct construction of larger decoder from the smaller decoders. So in this video I'm going to explain decoder ICs. So that is 74139. It consists of two 2 to 4 line decoder. That means it is a dual 2 to 4 decoder in a single package, and it has active low enable input and active high output. So enable input is active low, that means NAND gate realization, but active low outputs, right now active low enable input and active low outputs. So enable input can be used as a data input for demultiplexing application. That means so 74139 can be called as a decoder IC, or it can be called as a demultiplexer IC by using enable input as a data input. And see, this is the pin description. It is a 16 pin IC. In the left side it shows two select inputs, that is 1A and 1B, that is and select input for first decoder, and the 1Y0, 1Y1, 1Y2 and 1Y3 are the data outputs, and 1 is the enable. And observe the right side, 2E enable input for the second decoder, data inputs for decoder and select inputs for demultiplexer, 2A and 2B. 2Y0, 2Y1, 2Y2, 2Y3 are the data outputs for second decoder or second multiplexer. That means either it can be used as a decoder or it can be used as a demultiplexer. So it is a 16 pin IC, and this is the function table. So input side we have enable input and select inputs. So here A is LSB and B is MSB. So whenever E is I, that is 1, means since it is active low, it is disabled. So whatever may be select inputs or data inputs or all outputs are I, that means all outputs are not selected. So since again active low outputs, I means not selected. So in the remaining 4 rows, E is L, that is low means 0. So 0 means selected. So based on the select input values, corresponding output will be selected. Here L means selected, H means not selected. L means low, that is 0. H means I, that is 1. So this is the corresponding function table of 74139. Remember, it is a dual 2 to 4 decoder, or it can be used as a demultiplexer. 4:1 demultiplexer with 2 select input. 4:1 demultiplexer with 2 select input. So demultiplexer means opposite of multiplexing operation. 4:1 mux or 1:4 demux and 2 select inputs. So let's see next IC. 74138, and the corresponding pin description. So from the pin description we can see there are 3 select inputs or data inputs A, B, C, and there are 8 outputs Y0 to Y7. So we can say it is 8:1 demux with the 3 select inputs, or it is a 3 to 8 line decoder, or 8:1 mux with 3 select inputs. And observe the pin diagram, it has 3 enable inputs. 2 are active low, that is G2A, G2P and G1. It is active I enable input. So it has 2 active low enable input and 1 active I enable input. So these input reduces the need of external gate or inverter when expanding. That means when we construct the larger decoder, so it reduces external gates. So with this we can implement 24 line decoder without external inverter, and we can implement 32 line decoder with the only one inverter, So again, enable input can be used as a data input for demultiplexing. So if you use for data input, it will be 8:1 demux with 3 select inputs. So this is the corresponding function table. Okay, say observing the input side, enable input. Under the enable input, we have written G1, G2 star. Here G2 star means it can be G2A or G2B. And in the select input side, CBA, that means A is LSB, C is MSB. In the output side, Y0 to Y7. Observe the first row, that is G1 is X, that means don't care. G2 is I. So G2 is active low enable. If it is I means not selected. I means not selected. So whatever may be CBA, whatever may be select inputs, all outputs are I. That means not selected. Similarly, second row, G1 is L. So 0 means disabled. Correct? Since it is active I. And whatever may be G2 dash. So since G1 active low and active I enable input is low, whatever may be the select inputs, no one output are selected. All outputs are all I. So observe the third row, G1 is I, third and remaining row, the remaining rows. G1 is I, so it is selected. And G2 star, that means either G2A or G2B is low, that means selected. Active low input means low means selected. And based on the CBA, corresponding output is selected. Again, here L means 0, H means 1. So this is the function table of 74138. Remember, it is a 3 to 8 decoder or 8 to 1 demultiplexer with 3 select inputs. Okay. So now let's see Bcd decoder. That means to perform decoding of Bcd. That means Bcd means binary coded decimal. That is the input, and it decodes corresponding decimal number. So observe the block diagram. Inputs are A, B, C, D. That means there we give binary coded information of decimal digits. And observe the outputs are 0, 1, 2 up to 9. So it decodes. See, suppose 0 is coded as a 4 zeros and its select output 0. And 4 is coded as a 0, 1, 0, 0 and it decodes it as a 4. That is what BCD to decimal decoder converts BCD into decimal digit. Correct? So see, this is a function table. Input side A, B, C, D. So D is LSB, A is MSB, and outputs 0 to 9. So if all the inputs are 0, 0 is selected, 0 output is selected. If it is 0, 1, 0, 1, that is 5 output is selected. And if it is 1, 0, 0, that is 8 is selected, remaining are not selected. So this is the function table. And similarly we write the expression. So for output 0, the expression is A bar, B bar, C bar, D bar. For output 1, the expression is, the corresponding combination is 0001. So A bar, B bar, C bar, D. Similarly for output 7, A bar, B, C, D. Like that we write the expressions right now. So yeah, these are the expressions. And the corresponding circuit diagram. Here we use AND gate. Since it is a product term expression. SOP, sum of product expression. It has only one products. Okay. So this is about BCD decoders. Now we see another industrial ICs, that is 7445 BCD to decimal decoder. So as we discussed in the previous, that is general, that is a general design. Okay na? So now we'll see industrial IC, that is 7445. It is a decimal BCD to decimal decoder. It is also called as drivers. Okay. So general description, it consists of 8 inverters, 8 NOT gate and 10 4 input AND gate. It consists of 8 inverters and 10 4 input NAND gate. And the inverters are connected in pairs. Inverters are connected in pair to make BCD input data available for decoding by the NAND gates. That means we make a pair. So BCD input means 4 inputs, correct? 4 inputs, A, B, C. So for 4 inputs, for each we use 2 NOT gate, 2 inverters. For 4 inputs, we use 8 inverters. Okay. And full decoding of BCD input logic ensures that all outputs remain off, that for a invalid. That means BCD means we consider only 0 to 9, 0 to 9. So again, if it is 4 input, we can write up to combination up to 15. So 10 to 15 are invalid, 10 to 15 are invalid. So this decoding logic makes sure that all outputs remain off for the invalid combination 10 to 15, 10 to 15. So and the features of this decoder is it has high performance, and we use a NPN output transistor, and it is designed to use as a indicators or as a relay drivers, or we can use it as a open collector logic circuit drivers. And also high breakdown output transistor are compatible for interfacing with the most MOS, that is metal oxide semiconductor integrated circuit. Metal oxide semiconductor circuit. Okay, na? So this is the corresponding circuit diagram. As I said, 8 inverters are used in pair for 4 inputs, and we have a 10 the 4 input NAND gate. Output of NAND gates are corresponding to outputs 0 to 9, and this is the pin description. Again, it is a 16 pin IC. Observe the inputs, 4 inputs, that is A, B, C, D, and 9 outputs 0 to 6 and 7, 8, 9. The remaining 2 pins are VCC and ground. Yeah, this is the function table. So again, here A is used as a LSB and D is used as a MSB. Okay, na? So input side DC, BA, and output side 0 to 9. Since outputs are active low, because NAND gate is used, NAND gate, but inputs are active high. Inputs are active high. So one more column is added. There it indicates decimal number. So for 0, 0 output is selected, that is 0, remaining all 1. For 1 output is 0, the remaining all 1. For 7 output is 0, remaining all 1. And in the red color, it is shown indicated, invalid. So invalid means all 1 active low output, remaining off. Okay, na? So this is about decimal to BCD decoder. Now we'll discuss encoders in the next video.